Sorry for that. So some are positive and some are negative. We know that because some of the values are positive and some are negative. And when you add them together, together they are closer to 0 than figure 1. Okay, now the closer they are to 0, the less errors you have, because if we add these together, these two cancel. So 2 and negative 2 will cancel. 2 and negative 2 will cancel. We only get 4. We only have a difference of 4. Whereas if we add these together, we have negative 4. We'll add this. We'll get negative 5.2, negative 8, 9, negative 9, and then negative 9, negative 14.6, negative 14.6. That's the total errors in the difference from the line. And this one is a lot less, where we only had a difference of 4. Okay, so we want to keep them as close to the line as possible, as many of the values as we can. Okay, all right, so there's this next question, question C, and you can do this one on your own. Again, pause it, give it a shot, and then I will go over it with you, or unpause it and we can go over it and see what you get. So give it a try. You don't have to do, I don't have to do all of them with you guys. Okay. This one will take a little bit of time, so maybe 10 to 15 minutes or so. Okay. Okay, so you've given a shot, and let's see what you got. Okay, so what is your predicted model? Well, I'm not really sure. So what I'm gonna do is I'm gonna graph it first. I'm gonna plot all these points, and then I'm gonna draw my line after that. Okay, so I'm gonna plot points first, and then draw my line. Okay, all right. So I go all the way to. Oh, and be careful, because the way that they ask you this is, I think, really important. So let's go down here, and it says plot the given area and time. Because area is mentioned first, that's your x value. Time is mentioned second, so that's your y value. Okay, so this is the few rare occasions where time shows up here, and that's your y value, and then here is your area or your x value. Okay, your x value. So we should get something like this. I'm gonna go by ones. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, even though I don't get that far. And across my y values, I'm just going to go by 2s. 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26, 28. Okay. All right, so you're going to plot some points. My points are going to be 1, 3, I believe. 1, 3, and 3, 8. 1, 3, 3, 8, 3, 8, 5, 12, 8, 20, 5, 12, 8, 20, and then lastly 10, 25. 10, 25. Right, no, it's too long. 10, 25. All right, so we have a few options here on how you want to graph these, and what I'm gonna do is I'm gonna draw my line first, and then I'm gonna figure out that equation. Okay, now I think that I'm gonna give it a shot. It doesn't always work this way, but I'm gonna do what the first person did. I'm gonna connect my first dot to my last dot, and it looks pretty good. Okay, it doesn't always work out that way, but this one seemed to work out pretty good. So I'm gonna stick with that. Here are my points. I've got 1, 3, and then I've got 10, 25. Okay, and when I highlight these are my y values, and these are my x values. Okay, now I'm gonna label them so I can use my equation. So that's x, that's x. I'm gonna call this x1 down there, and call this one x2. Since this is group 2, this is y2, and this one is y1. Okay. Now, in order to solve this, I need to find this equation. Okay. And you can use your point slope formula. And if you don't remember your point slope formula, it is y minus y1 equals m times x minus x1. Keep in mind that this x1 is the same one down here. This y1 is the same one that shows up down here. And your m we have to figure out using your y2 minus y1 over x2 minus x1 equation. Okay. All right. So let's do our slope first to find that m. So slope, or m, is equal to our y2, which is 25 minus 3 over 10 minus 1. 10 minus 1. Again, slow down if you need to. Pause the video so you can keep up with me. I don't know if I'm going too fast or too slow. There's no one here to tell me to slow down or speed up. And our slope ends up being, let's see, 25 minus 3 is going to be 22 over 9, which is, I guess, just 22 over 9. If we check that into the calculator, 22 divided by 9 is 2.44. So 2.4. I'll just round it to 2.4. Okay, that's my equation. And I'm going to use this equation right here. Okay. All right. So y minus my y1, which is, in this case, y1 is right down there, 3, equals my slope, 2.4, times x minus my x1 number, which is 1. Okay, so I can simplify this equation. Y minus 3 equals 2.4x when I multiply and distribute, times negative minus 2.4. Okay, now I just need to move my 3 over so I can get my y by itself. Plus 3, and they cancel, and I end up with y equals 2.4 plus 0.6. Okay, 2.4x, sorry. Okay, now we can kind of, there's our line of best fit, that's our equation. Y equals 2.4x plus 6. Now, you might have gotten a different equation than I did, and that's completely fine. We don't have to have the exact same equation every single time, but your line, you should use the same process in finding your equation for your line. Okay, it says describe the residuals, so that means I need to calculate my residuals. So I'm going to use this equation here, and I'm going to input all of the x values from up here. I'm going to input all of these. So y equals 2.4x plus 6. So y equals 2.4x plus 6. So y equals 2.4 times 1 plus 0.6. I believe it's 0.6. Just forgot the decimal. Y equals 3. Predicted 3. Residual 0. And we know that because when we graphed it, I used this exact point. That's what I kind of expected. I know I should get the same thing for the end, 25 with a residual of 0. So I only have to do those 3 in the middle. Okay, y equals 2.4 times 3 plus 0.6. Y equals 7.2 plus 0.6. Y equals 7.8. 7.8. And we get a difference of 0.2. again times 5 this time, plus 0.6, y equals 24 equals 10, 12 equals 12 plus 6, y equals 18, a difference of -6. Is that right? Did I make a mistake there? 5 times 2.4 is 12. Oh, that's 0.6. There's my mistake. Keep forgetting that 0.6. I get 12.6. There we go. 12.6. And I got a difference of -0.6. And then lastly, y equals 2.4 times 8 plus 0.6. Y equals 16, 19.2. 19.2 plus 0.6. Y equals 19.8. And we get a difference of -0.2. Okay. Now, these residuals are actually not very big at all. They're very close to each other. 2 negatives, 1 positive, and a couple of zeros. Okay. So we did this. We did this. We did this. We need to find the residuals. Okay. So we could say our residuals were 0, 0.2, -0.6, and -0.2. Yours were different than mine, and 0. My total residuals were, if I add these together, -0.6, -0.6, and that's very close to 1, or sorry, close to 0, which I want, which is a low number, and that means my line is accurate. Okay, the further away it is from 0, the less accurate it is. So, all right, so summary, residual is 0. So if our residual is 0, what that means is residual 0 is the line is very, very accurate to the actual data points. Or maybe we could say our prediction. The line, maybe we should put this here, the line, the predicted line is very accurate to the actual data points. And then we could do the same thing here. We did this yesterday with the last class when we wrote this. A negative residual represents the predicted line. The predicted line is too low, or is, sorry, the predicted line is above the actual data points. And then the reverse is true if it's positive. The predicted line is below the actual data points. Okay. All right. So that finishes off this section, which we didn't finish last class. This one should take you a little bit of time. Same thing with this one, should give you a little bit of time. Go ahead and pause. Maybe this might be a good time for a break. Stretch out a little bit. 5 minutes. We'll get on to the next lesson.